Question 2. In question 2, we know that x is uniform ranging from a to b and y equals to x squared. Because x is uniform in ranging from a to b, we can easily figure out the density function of x should be in the form like this. fxx equals to 1 divided by b minus a. If x is ranging from a to b and should be equals to 0 in otherwise. And now given that we have known that the density function of x, it's simple to figure out the distribution function of x by the formula that the distribution of x should be equals to the integral from minus infinity to x, the distribution of x, fx alpha d alpha, and should be equals to, in the form like this, should be 0 if x is if x is less than a, and should be 1 divided by b minus a times x minus a if x is ranging from a to b, and should be 1 if x is more than b. That's the distribution of x. And we know that y equals to x squared. Since that y equals to x squared, x can be both positive and negative y square root. And given by the distribution and given by the density function of fyy equals to the density function of x divided by the derivative of gx absolutely value at x equals to g inverse x, we can easily figure out when y is ranging from a squared to b squared, the density function of y equals to the density function of x divided by g derivative absolutely value x equals to y square root plus the same form, and when x equals to minus y square root, and that should be 1 divided by 2 times b minus a times y square root. And by the similar formula, we can easily figure out that when y is ranging from 0 to a squared, the density function of y equals to 1 divided by b minus a times y square root, and in the other conditions, the density function of y just equals to 0. And now we have figured out the distribution of x and the density of y. Now in the second case, we have been given that a equals to minus 1 and b equals to 3. In this case, we can simply similar the density function of y. In this case, fy equals to 1 divided by 4 times y square root when y is ranging from 0 to 1, and should be 1 divided by 8 times y square root if y is ranging from 1 to 9, and should be 0 in otherwise. And now, given by the formula of the distribution of y equals to the integral from minus infinity to y, the density function of y alpha d alpha. And now we can figure out the distribution function of y is 1/2 times y square root if y is ranging from 0 to 1, and should be 1/4 times y square root plus 1 if y is ranging from 1 to 9, and should be 1 if y is more than 9, and should be 0 in the otherwise. Now we have figured out the distribution, and now we have figured out the distribution of y. Now we have to figure out the expectation of y. Actually, the expectation of y should be in the form like this. It should be the integral from minus infinity to infinity y times the density function of y dy. And now we can divide into the two integral, that is one is from 0 to 1, y divided by 4 times y square root dy, plus the second part from 1 to 9 integral, y divided by 8 times y square root dy. And the final result should be 7 divided by 3. That's the answer of the second question. That's all. Thanks.